Hello, I'm Patty Simpson with Simpson Math. In previous videos, we looked at a binomial distribution. In this video, we're going to look at the expected value of a binomial distribution. Let's first take this spinner here. Notice that we have two outcomes, to win or to lose. We have a fixed number of trials. We're going to spin it 40 times, and the probability remains the same. We win 1/4 of the times. Every time. That probability of 25% or 1/4 of the time stays the same. So this is a binomial distribution. So I want to know though, how many times do we expect to win? Well, the probability we win is 1/4. So we should win 1 out of every 4 times. So if we are winning 40 times, well, we could do a little bit of multiplication and just say 1/4 times 40, or divide this by the 4 so that we get 10 times. We would expect to win 10 times. So, you know, if I have one student spin it 40 times, they may not win 10 times, they may win 12 times, and someone else spins it 40 times, may win it 8 times. So we expect to win it 10 times, but it doesn't mean that it always happens. But on average, if I were to take this student's 12 and that person's 8 wins and add them all up and divide by however many spin it, then I would expect to get 10. On average, that's what we would think we would get. A planted radish seed germinates 80% of the time. A gardener plants 800 seeds. How many seeds would we expect to germinate? Again, the plants can either germinate or not germinate, so it's got two outcomes. The probability remains the same at 80%, and there's a fixed number of trials of 800 seeds. So this too is binomial. And 80% of those 800 seeds we would expect to germinate. So I'm just going to take 80% and multiply it times 800. Or we can get 80 over 100 times that 800. So I just get 640 seeds. So I would expect 640 seeds to germinate. Now, it may not do that every year. I may not get exactly 640, but if every year I plant 800 seeds, then on average, I would get 640 seeds. So that's what that expected value is. It's just the average. On average, this would happen. A game at a casino has 85% chance of winning for the house. 15% of the people play the game in a day. How many payouts does the casino expect to make during the day? Well, again, this is binomial because we have two outcomes. The casino can pay out, or it can make money, can win for the house. We have the same number, the same probability. It's an 85% chance that they win every day. And it's 15,000 people is the fixed number of trials. So this is also a binomial. We want to know what's the expected value, or what's the expected payout. Now notice that to pay out is the complement of winning. These two, you know, one of those is the success and the other is the failure. So to find the probability that we pay out, we're going to actually look at the complement of that 85%. Remember, to find the complement, we take 100% or 1 and subtract the 85%. So the probability that the casino pays out is 15%. 15% of the time they pay out. So now I'm going to 15% of those people are going to win some money. The casino is going to pay out to them. So again, 15% is 15 over 100 times that 15,000. Do a little reduction ahead of time. I end up with a 0 in the end, and 15 times 15 is 225. So that means that the casino expects to pay 2,250 payouts during the day. Now, they may not get exactly that every day. Sometimes that may be less, sometimes that may be more, but on average, they would expect to pay out 2,250 times. So they can start to make plans around that. So the way we find expected value for a binomial distribution is we take the number of trials, times the P, the probability for success. And that gives us our expected value. And all our expected value is an average. So that M, remember, meant the mean or the average. That's also our symbol for expected value, because all expected value is on average what we expect. And remember that N is the number of trials in a binomial, and then the P is the probability for success. So to find the expected value, we just do the number of trials times our probability, and that gives us our expected outcome, or on average what we should get. Math made simple at Simpson Math. Thanks for watching.